Welcome back to TechPub's Postgres series. Today we talk about data types and the various things you can do with the numerous data types that are in Postgres. We get started with the basics, strings, numbers, dates, and so on. And then we get into more advanced stuff. What can you do with specialized data types like IP addresses and MAC addresses? And finally, we get into ridiculous territory with arrays. All right, so we have Postgres installed. And what I want to do now is take a tour through the data types, because I think this is one of the more exciting features of Postgres. Alongside the RavenDB stuff I've been doing with Orin, I have to say Postgres is amazing with some of the stuff it can do. Hopefully we can show that today. So what we have right here is Rob Sullivan is going to have at it with his type samples table. So straight away, I'm looking at this, and you have got something strange that I think is going to be strange for a lot of people. Row ID serial. What is serial?
Okay, serial is kind of like a mask or an alias for something called a sequence. And what a sequence is, if you're coming from the SQL Server world, you're used to, when you create your table, you'd say row ID, and you'd call it an int, and then you'd go into the identity, and you'd give it a seed value and an increment value.
Not null, primary key.
Yeah, not null, primary key.
All this increment. Yeah, there's a big long incantation for that.
All this
stuff.
decoration.
Yeah.
Well, in Postgres, it wants to make your life easier, and it just wants you to get to having fun with your data. So it has this thing called a sequence, and the serial is a mask for that. And what a sequence is that, Rob, what's one of the use cases that developers like GUIDs?
Well, they're completely unique, I guess. I don't know. That's what at least people think. And then you can also, you can also create a GUID on the client and send it in, because you might want to work with it, I don't know, before you do it. And that's kind of a problem with using SQL Server. If you use auto increment, if you need to know the key beforehand, it's kind of a pain in the butt.
Right. They like to know the value ahead of time. And what sequences let us do, but why a DBA hates a GUID is because it is a gigantic data type.
Right. And
in the database, as we've talked about, space is money and space is performance. So the way that we get around it in the Postgres world is through something called a sequence. So
curval. What is that? Current value of a sequence. Look at that. So
right. This behind the scenes, it made this it created a sequence on its own, and this is the name it gave it. I looked it up off camera. And so now we query, and if we want to know the current value of it, it's 1. If we want to know what the next one is before we insert, it'll tell us. So now that we've called the next value, and we do this, before we inserted, or if we just use the syntax that I used here, it'll do it in real time like you're used to with an identity field.
Mm-hmm.
And now we're at current values at 2. If we want to know, before we insert again, we just call it, and we know ahead of time. And what this does is this makes for incredibly fast inserts. So fast that, my friend SQL Server has gone and adopted this for 2012, SQL Server 2012.
Really?
Oh, it is great. It's wonderful. And I like that it kind of builds a bridge between me and the developers of them wanting to know the value ahead of time to work with it, and me wanting a very thin primary key.
Okay. Wow. So if you're a developer and you want to use something like this in your application, let's say you're using something like Entity Framework, you'd have to step out of the abstraction. Well, I guess you wouldn't. You could write a function in Postgres and then expose that to Entity Framework, and then that function could have curval or nextval in it.
There's lots of ways around it. The current versions of Entity Framework, I just haven't had any success getting this to work. Now that with SQL Server being on board with it, I imagine that Entity Framework 4.3.2, Community Update 7, Release Candidate 3 will probably start to incorporate this type of thing.
So let's talk a little bit more about numbers and numeric types. There's no big surprises that I've seen with numbers. There's still some floating point concerns using doubles versus decimals, but they have floats, and there's nothing too crazy. Although there's one thing that I found noodling around the Postgres documentation that I think is interesting. So if you do me a favor, Rob, put in a floating point type here.
Let's call it my price.
Try
and
float. Yeah.
Float. Okay. Build this.
Yep. Okay. And so now let's insert some values in there. You got nothing.
Type samples. my name, my price.
And then put in infinity capitalized.
And the word?
And yes, the word infinity.
Rob, this is a numeric data type.
It's a keyword that Postgres will operate on, hopefully. I think it works with floats. Let's see.
So I'm inserting two strings. Huh.
Okay. This is interesting, and I'll tell you why it's interesting. Because there could be a time where you just don't know what a value is going to be. It just needs to be above every other value that you have. You don't know what it is. It's just always going to be above another one, which is pretty funny. So you can also do negative infinity. There you go.
Hold on. Let me throw that one in. Let me go to a new line.
That's actually just a negative symbol. And I think it's all got to be together.
All close together?
Yeah. Okay.
Now when we order by my price, negative infinity.
And then finally, one of the funnier ones is NAN, where the N's are capitalized. And the A is lowercase. There you go.
I think I know what that is.
Not a number.
Not a number.
So it's interesting how it evaluates not a number. It's also interesting why you would even need such a thing. But there are times when you might just want to have something in there that is just, bigger than any number you have in your system, or maybe less than any number you have in your system, or it's just not a number at this time. It's different than having, so this is probably what you put into a column that won't allow nulls, but you don't know what that number is just yet. So
Bingo.
It's not a thing, right?
That's exactly what I was thinking. This gets you out of that null trap of, on the data side and data integrity side, you just hate seeing nulls everywhere. You have no idea what it is.
Yep.
Whereas, using something like a NAN, it gets the developer out of having to commit to a value, but lets me know that, okay, this is intentional. Whereas a null, I have no idea if that's intentional or just, no one ever got around to it, or if they meant it to be null. And that's why I love this on the data side.
Interesting. Okay,
cool.
So
that's fun.
Yeah, well, let's keep moving. For those who I'll just throw this in there too. Postgres also supports the concept of money. I personally, as a developer, never used the money type because it's pretty much driven into the dollars and cents sort of standard with the .00. But there's denominations out there. If you want to support globalization, sometimes it's better just to use an integer. You go with pennies. I know that's old school, but whatever you want to do. But yeah, precision and scaling, all that stuff works with Postgres. All right, Rob, so we're going to take a look at strings. And to me, I found this to be interesting when I started throwing TechPub together. I was expecting to find an nvarchar field. It wasn't there. And I said, oh my God, what are you talking about, Postgres? What if I wanted to do internationalization or something like that? Turns out the story's a little more interesting, yeah?
Yeah, I hit the same thing too, because a week doesn't go by where I'm not stuck in the nvarchar versus varchar debate.
Yes.
Because, weird things happen. And so if you're using an ORM, you'll typically do something like, say we have this my name column here. Mm-hmm. You'll go my name, string, right? Mm-hmm. And from the developer side of things, you're done. That's all you care about. But on the database side of things, that goes and makes an nvarchar with a character or with a performance killing max.
I've seen that with Entity Framework code first, and it kind of made me laugh a little bit. That sounds crazy.
Your laughs are my tears. But let's hop over to SQL Server and look at why this is a big deal, and then we'll come back and see how Postgres handles it. Just to establish a base from SQL Server.
Okay.
And then maybe see if Postgres can handle it a little more elegantly. So we'll build out our table. We'll do an nvarchar 20. This means that an nvarchar basically means for SQL Server to understand Unicode, it has to double our size, which drives me nuts because, size and the data types is a big deal for me. And when my boss is telling me to make things fast, and I'm seeing that we have, half the database has gone to black hole space of incorrect data types, that doesn't look good on me and our app.
Right.
So we create our table, type samples, and we'll insert into type samples. My name, values. We'll start easy with Rob.
Okay.
And then we'll query it. Not too bad, right?
Yeah, looks good to me.
So let's say that I have
Move to China.
moved to China.
That's right. Do we know what this this set of glyphs means? Are we offending people right now?
I really hope not, and I apologize if we are. So typically, since I carry more power in the company, I will have one, and we'll be using a varchar.
Okay.
Which means that when we go to this and select our data,
now I find that choice interesting because I've had this happen where you get back a bunch of question marks. That is invalid completely, although maybe not. What is actually going on there? Is it just literally inserting question marks, or is it saying, I'm confused, and the value is actually in there somewhere?
It's saying I'm confused.
Okay.
So converting from varchar to invarchar is very easy, and I could just run an alter table and get to invarchar. And without changing any code, we can still sample just fine. And when we go to query it,
what? Wait a minute.
Wait a second. We're in varchar.
Yeah.
Oh, but we're still getting question marks.
Yes. I hate
now
this.
We need to change our code.
Yeah. Okay.
And just so that it stands out. Now when we change our code to preface it with the N.
There we go. And that works. Now, if we went and how can we rescue the values in row 2 there? Because I know a number of people have come up against this and said, "Oh, how do I fix that?" Can you do an update or something like that?
I don't know if this will work. No, I think it's toast.
Wow. That seems wild that it wouldn't throw an error, it would just corrupt the data. Well, my opinion, and I'm not a DBA, you're a DBA. My opinion on this is if we didn't use the N prefix, and then it went in a way that SQL Server didn't understand, so it's probably lost data. Do you think that's right?
Yeah, there might be a way to salvage it by going down to the page level. But again, we've just incurred a bunch of work in a really awkward meeting with our boss.
Yes, exactly. Well, okay. Well, let's take a look at how does Postgres handle all this?
Postgres. So let's go back to let's just grab our insert. Let's see. Do we have anything in there? Okay.
Got to go to the end, but that's about it.
All right. So out of the box, we'll see if we can do this with no code changes. Just one thing like you're used to. And see, if we were on SQL Server, that's what we did start off with, but then we saw we had to throw an in.
Mm-hmm.
And to use the term from Oren, safe by default. There we go.
Wow. Yeah, that's cool. So
now we're doing high fives instead of a meeting with our boss.
Character varying for those, that seems kind of wordy, but you can rewrite that as varchar, right?
Let's see. Yes.
Okay. Well, that's cool. And to be clear, there's no nvarchar because you don't need it. And
nope.
Dun, 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 drum roll, I'm going to guess that the encoding that Postgres uses by default is, what is it, UTF-8? Yay. That's good to know. Dates, I swear, dates in a database have always been a bit of contention. And every time I look at a column and I'm thinking, okay, I want to use a date type here. And then there's like date and there's time. and then there's date time, and then there's timestamp, at least in SQL Server's world. In Postgres, it's worse. I mean, the dates and stuff that you can use in there, I mean, how do you choose which one? There's another one, there's timestamp, which is completely different than SQL Server's timestamp. And there's timestamp TZ, and we're going to take a look at each one of these.
Yes. And keep in mind that SQL Server's version of timestamp is kind of a beast on its own.
Yeah, it's like a binary situation. Now, you did timestamp without time zone. I'm looking at the return data. What's that check?
Check. This just, I want to show this because it's real easy syntax to get a constraint. So if in the SQL world you used to, add constraint and such, here we just throw on a check and put in the little function that we wanted to check. So when we go to insert into type samples, my name and born date, Rob, and let's see, 1/1/1970. So, not good.
I get that.
Let me go to 87. Yay, it likes it.
Tell me you weren't born in 87.
No.
You're going to make me feel real old. All right.
We're keeping the young people out of our database.
Right. So
we just put in the date here, and we got time.
Yeah. And so what, as a DBA, do you care about a date versus time? Is there any size constraints there?
Yes. This is why you see in the SQL Server world introductions of new data types like just date or just time, because they are a fraction of the size, and that helps out. But again, Postgres, we get that compression by default, which kind of, to me, it lets me not be so militant about every single choice. Yes. And then in SQL Server, you end up seeing a date and a time, and I believe we get that in Postgres as well.
Can you have two columns with the same name?
No, that's
silly person. Yep, there we go.
And there we go. Now, so we'll insert our data, and now we'll go to
today and all balls.
Right.
So just like the numeric types, there are special keywords. Today, look at that.
Today and all balls.
Zeros. I get it.
Yes.
All balls. Okay. That's an enterprise term, is it? All right, then.
Yes.
Interesting. So what other keywords do you have? It's like today, I'm assuming tomorrow and yesterday?
Yeah, there's all kinds. And it's fun. I like the kind of human readable element of this.
Yeah.
There's today, tomorrow, yesterday, the infinitive, the negative infinity.
That's in there as well. Okay, yeah, the infinity, of course.
Mm-hmm.
Interesting. Okay. So if I was, you just use timestamp, and I'm looking down here at the way that the output window is saying time without time zone and time without and I'm assuming that TZ includes time zone, right? Is that what you're going to show me here?
That's a pretty good guess.
So for those people out there who care about UTC, which should be just about everyone, UTC, for those who don't know, include a reference to GMT time, so you know time zone offset, so you know the real time relative to the users and so on. It's important stuff. And so you can just change this to -6. That's where you are. Is that right?
Correct. And
there we go. Look at that.
It's going to store it server time.
Time with time zone. So it stores it. Okay.
Yes. Now it's basing this on the server's time. So if we do, let's see,
so
+7, when we insert it, you're going to see that it changes the hour, but keeps the same time zone.
Oh.
Does that make sense how it's going to apply it on the insert?
Oh, yeah. Interesting. You said +7, but you wrote 4. I just want to point that out. So,
oh, jeez.
Well, so that put it to 4 hours later. Look at that. Okay, but again, it's relative to the server's time zone, which makes time calculations really nice for, let's say you have a client that does an insert and you know that they're at +10, which is where I'm in -10. Then you can show time relative to them. That's pretty handy.
Yeah, it's nice to have just a consistent mechanism like that you can base your rules around.
Okay. Neat.
So, how do you feel about something a little more exotic?
Oh dear, what are we doing?
Let's see. How about since we're getting close to lunchtime?
We are, aren't we? At -10 time zone. Oh, wait a minute. Don't do a raise yet. We still have a few other things to do.
Oh, what do you want to do?
That's right. I'll bring it up.
Oh, IP address in G. Let's see.
That's okay. Well, I wanted to talk about GUIDs and XML real quick and just touch on them before we go. You don't have to do it, but
Okay.
well, here, just do Control Z a couple times. Well, this is interesting. You know, it's the more that I play with Postgres, the more I see that, you know, you can tell when something is made by a set of engineers and then a set of engineers that also have to use the thing, which I think is really valuable for open source, an open source tool. Moving on here, we're going to start diving into some specialized data types. I have to say, when you're first studying Postgres data types, it is overwhelming. There's a lot of them, but I want to dive into some of those specialty ones. That's what I'm going to call them. Like, for instance, you brought up GUIDs before, and yes, Postgres supports GUIDs. They're called UUIDs. I just want to throw that out there. Also, it has an XML data type, so you can play around with that if you like XML, but they have some really compelling other ones. Let's jump into them, shall we?
And part of this rich ecosystem of data types are things like you might even take for granted, such as, oh, my IP address.
Yes.
How would you store this in SQL Server? You're going to have a weird string, and you know, you're just basically going to have to hack around that because it doesn't really understand that by default.
Yeah, some kind. Well, isn't there like, don't people use some kind of constraint checks with a regular expression or some kind of trigger that will throw an error if you try and insert anything that's not a proper IP?
Yeah, well, there's different ways to do that and try and enforce that, but the main point is that it starts to get really hacky, and it doesn't feel right. Does that make sense?
It sure does. So you have just uncovered the INET data type, which is pretty funny.
Yes. And I'm going to just try and simplify our insert statement here.
Okay.
So my IP, and let's see, 192.168. Oh, I can't type. So if you're used to the, you know, a typical text data type or something, or to store this,
it checks it. Look at that.
Then we fix our typo, and ta-da, we have it.
Wow, look at that.
So IPv4, that's not a big deal. That's pretty predictable, right?
Yeah. So are you,
let's see,
doing an IPv6 address?
Yeah, let's see if we can pull this off. So would handle IPv6.
Wow. Look at that.
How do you write a regular expression for IPv6?
It handled them both. My goodness. Okay, that's pretty darn handy. Yeah, there's all kinds of interesting functional types in here that you could tell someone just needed to solve a problem. They contributed to the project, and boom, they're in there. Like the next one we're going to play with, and it's arrays. There's an array data type, and you might look at that and say, well, why would I ever use an array? Well, the answer is when you're trying to do something like Oren and I did with his document database, where you have something like a tag, and you don't want to have a many-to-many, you don't want to have this ceremonial structure just for doing these contextual taggings. Why not just have an array, and then you can query on the array, and as you're showing here, it is so very easy to do with Postgres. It's weird because it starts to take on this document database veneer at this point.
Yeah, it's really neat. So, well, this doesn't look like anything you would ever see in the SQL Server world.
No, it's not at all.
It accepted that, and we select it, and oh, well, that's okay, but I really want to know. So we've just inserted this a few times, and you know, you can pretend, you know, some of these are chalupa or whatever. And if I want to select it out, I just do lunch food, you know, 2, and that will be our tacos.
Oh, wow, look at that. Okay.
But what if we want to search for taco? How would we do that?
Well, can we do lunch food 2 equals taco? Just, I don't know.
Yeah.
It seems like that would be the case, right?
Ta-da! But let's say
Wow.
we do.
That means you have to have positional knowledge. That doesn't quite work.
Yes. And
Nachos, flautas. You guys have weird Mexican food over there.
we have real Mexican food over here.
No.
Type samples and show. Okay.
Yep.
So we should have 5 rows of tacos, but when we do this based on the 2 assumption, we're going to miss
the last one.
That. Right.
Okay.
So how do we get around that? Well, to do that, we might say where taco equals any lunch food.
I think you got a extra quote in there, or a missing quote.
A missing quote.
After taco. Yeah, there you go.
There we go. All 5.
Look at that. Where taco equals any. I love the way that reads. It's very human readable.
It's very fun. And like, there's sometimes when you're designing out your schemas and stuff where you painfully break into a many to many or something, just because you don't have any sort of concept of array. Say here, say this is going to be a really predictable, dudes can only order 3 things type scenario. And typically you might have to break out into a another table to handle that, or say we go to 4. I'll do this one for you. You're dealing with these joins and this mini relationship that people don't like. Whereas for something very small and controlled like this, having the ability to have an array, and a queryable array, is really fun and exciting. And I like that flexibility that it gives us.
So let's see how you update. So let's say we want to update row 4.
Well, it's going to be problematic because this is just a display type thing.
Oh, right.
Mechanism. We don't have a key.
Okay, that's okay.
So if we want to get rid of all the horchata off our menu, say we lost the deal with our supplier, we could come in and run an update on the element.
Okay.
And there we go.
So that query means you need to know the position in the array. What if I just wanted to make sure that, everything in there said water and, not horchata? Is there a way to just select by individual key in there? Or not key, but I guess value in the array?
Updating like this is going to start to get a little more complex. And that's why, you don't want this to be like your blanket solution for everything.
No, of course.
And when you start hitting a certain level of complexity, that's, I think, when you want to start hugging the relational world and break out probably into another table.
That makes sense. Okay, well, in looking over the documentation on the Postgres site, it's pretty complete. But yeah, it looks like arrays are functional, but simple, I think is the best way to put it. You can append things in if you want. You can query by slice. You can change and update things like as we've shown. But really, if you need anything else, you should just do a lookup table.